Hello, this is Fred Woodall doing video problems for homework set number 9. For number 1, we were asked, a flare is fired vertically upwards from the ground at 25 meters a second. Find the height of the flare after 3.5 seconds. Okay, starting off, I will write a small picture. So the flare starts off at 25 meters a second velocity. We know velocity is equal to dx over dt. So all we have to do is set that equal to 25 meters a second. Bring the dx over dt equal to 25. Okay, now we move the dt over by multiplying the whole thing by dt. And we want to know where the height of this flare is after 3.5 seconds. So 3.5 seconds from t equals 0 to t equals 3.5 seconds. So what we want to do is move the dt over, so that cancels that dt out. So we get the change in position equals 25 times the change in time. Now we integrate this whole thing. When we integrate dx, we just get x. And when we integrate 25 from 0 to 3.5, we get 25 times t evaluated from 0 to 3.5. That means x, the position, is equal to 25 times 3.5 minus 0, which equals 87.5 meters. That means the flare is at a height of 87.5 meters. Now we ignore gravity and all that in this problem because obviously flares go up and never come back down. For number 2, we were asked the equation x squared over 9 plus y squared over 4 equals 1 describes an ellipse. Find the volume of the solid obtained by rotating the ellipse around the x-axis and also the y-axis. These solids are called ellipsoids. Okay, so we want to start off with is we know that the equation for the ellipse is x squared over 9 plus y squared over 4 equal to 1. Okay, so the original equation for ellipses is x over a squared plus y over b squared, which means that a is equal to 3 and b is equal to 2. The reason we know that is because the square root of 9 is equal to 3, which is equal to a, and the square root of 4 is equal to 2, which is equal to b. Now, we can draw a small, not good graph, and that means that y goes from 2 to negative 2, and x goes from 3 to negative 3. Not too bad by my standards. So, now first what we want to do is just act like it's just x over a squared plus y over b squared equal to 1. We want to find an equation for x to rotate it around the x-axis. We do this by solving for x. So we got x over a squared equals to 1 minus y over b squared. Now, what we do here is we pull out the x over a. We get x over a squared equal to 1 minus y over b quantity squared. I'm going to leave this way because it makes it easier. Pull the a up to the other side. Then what we want to do is make an equation from x squared. So we know that the volume is equal to pi x squared dy. Now the reason it's dy is because we're not really changing anything in the x coordinate system. We're rotating it around the x-axis. So what we want to do is change where y is around the x-axis, because we're not really changing anything around the y-axis. This is what we'll be doing next. So we know this, and we know the equation for x squared. So we plug in x squared, we get a squared pi times 1 minus y over b quantity squared dy. Now we integrate this. So integral of a squared pi 1 minus y over b quantity squared dy. We want to integrate this from -2 to 2. We're going to keep a and b as they are until we get to the final part, which will be easier because you'll get a cube from this integral, and that's not fun to do. And my calculator ran out of batteries, so I still have to get some. So now what we're going to do is we're going to take out the a squared pi, because that won't be affected by the integral. We evaluate this integral, and we get a squared pi times y minus y cubed over 3b, evaluated from -2 to 2. This is evaluated from -b to b. So we'll replace this, and we'll get a squared pi times y minus y cubed over 3b, all of that evaluated from -b to b. Now we'll just get b minus -b, which will just come out as 2b in each of these y's. So we'll get a squared pi times 2b minus 2b cubed over 3b. So we can 3b squared. I guess this should be a squared over here and a square right there. Okay, my bad, I forgot to put the square in there. So then we can cancel out that 3 with this b squared over here, under it. Then we can do this by 2 minus 2/3 b times a squared pi. Now what we get from this will be 4/3. Yeah, 4/3 b a squared pi. So do 4/3 a squared b pi. Okay, now we can plug in a and b. So a equals 3 and b equals 2. So then what we do, plug it in obviously, and get 4 over 3 times 3 times 3 times 2 pi. Cancel out one of the 3's. You get 6 times 4, which is 24 pi. And if you look it up, the area for an ellipse rotated around the x-axis is in fact 4/3 a squared b pi, which turns out to be the correct answer for this. Next, we would do around the y-axis. So I'm going to draw a picture just to help us out. So -3, 3, 2, and -2. This time we'll be rotating around the y-axis. To do that, we start off by obviously finding an equation for y squared, because we know that v equals pi y squared dx. We need y in the coordinate x system. So we know y over b quantity squared equals 1 minus x squared over x over a quantity squared. We get this from the x squared over a squared plus y squared over b squared equal 1. Now, what we're going to do here is obviously, fill out the square on here. Keep this one to make it simpler in the end. You can get y squared over b squared equal 1 minus x squared over a squared. Then, bring the b up. So you get y squared equal b squared times 1 minus x squared over a squared. Then we plug it into the volume equation and integrate. So we get v equal to pi times b squared times 1 minus x squared over a squared dy. Integrate this. We're going, this time, since we're doing y, we're going to be integrating from -3 to 3, or in other words, -a to a. Then v equals pi b squared, because that won't be evaluated in the integral, -a to a of 1 minus x squared over a squared dy. Integrate all this, and you get pi b squared times x minus x cubed over 3a squared. Evaluated from -a to a. And just like last time, you'll get a minus -a in each of the x's. And you get 2a. So, v equals pi b squared times 2a minus 2a cubed over a squared. Over 3a squared, sorry. Cancel out the 3 in the top and the a squared in the bottom. You get 2/3 a. 2 minus 2/3 a is just 4/3 a, just like the last one. So we get 4/3 pi a b squared. Plugging in a and b when a equals 3 and b equals 2, you get 4/3 pi times 3 times 2 quantity squared. 3's cancel out, and you get 4 times 2 squared, which is also 4. So you get 16 pi, which is equal to the volume. Now, it's kind of hard to understand why that would be true, but it is because of depending on the axis that you rotate it around. Like if you rotate it around the x-axis, you'll get 4/3 pi b a squared and not 4/3 pi a b squared, because you were going around the x-axis, so you can be squaring the b instead of the a, which would be the x-axis, which turns out to be the right answer for this one and the right answer for that one. 24 pi and 16 pi relative to their horizontal and vertical axis flipping. Thank you.